Hi students, how are you all? So again MCO has been extended until May 13, May 2nd week. So I have to wait for another announcement. So we can't afford to wait until our school reopens just to catch up with the syllabus. Although your exam is next year March, it looks like a long time for exam, almost a year for your exam. So whatever it is, we have to go on with our lessons, and we have no choice. Maybe some of the chapters that we are learning, maybe we can refresh back later during the revision time. Okay, so I already finished with all the electricity quite some time. I think almost about 1 week plus. I give you time to do some exercise and give a lot of questions. And I was repeatedly posting in Telegram and also in the Google Classroom, right, to feedback the questions that you all have done, or you all are not sure how to do it, but I didn't get any feedback from you all. So I assume that you all maybe can do the questions, right? Or maybe want to ask me later. So no problem, you can ask me much later also, but I hope you all are following my lessons. And I already done up to 8 video clips, part 8 until the last lesson. And maybe I'm seeing how many of you are viewing, and quite a lot. In fact, I think outside is also viewing the clip. So please go through the clips and refer the questions and the notes and try your best to do it. So again, since it's in a video form, so you can always pause and rerun to see and to get a better understanding. Okay, so to continue our lesson today, we are going into chapter 3, Electromagnetism. Okay, it's a rather, I would say it's a rather one of the difficult chapter in your Form 5 syllabus, and this chapter is quite long, quite a lot of things to be learnt. The thing is that in this chapter we have number of laws and also rules, okay, to know, and with, of course, together with some formulas that you have to know to understand and to tackle this chapter. Okay, so definitely there is one essay question and also a structure will come out from this chapter, because this chapter includes electricity also. You can see the term electromagnetism. That means there is an electric there. The electrical concept also is there. In fact, in some of the sections, when you learn about generator and motor and transformer, the electricity idea will be applied over there. Alright, but on the first section, we are more focusing on the magnetism part. Alright, so if you look at this is the overall concept. So this part is not in your notes. So I hope you can copy all this, right, as an introduction, and also to get a better understanding of the concept that you are going to learn in this chapter. Alright, so for today we try to cover the first part. So that is from page 61 to 63. This is the page that I am going to cover today with you all. Alright, the first part of it, and the second and the other parts will go a bit slow because a lot of things to learn, and of course all are interrelated. But one thing you have to be careful in this chapter: if you are not very careful about the terms and the words, the terminology that they are using on understanding the concepts, you will get rather confused. Okay, like for example over here you can see Fleming left hand rule, then after that you have Fleming right hand rule, then you have Land's law, alright, then you have a Faraday law. So a lot of things are there. So all these are very distinguished. They have their own concepts and understanding and the ideas they are trying to tell. So if you are not very careful, you may sometimes feel a bit confused, especially when you do the questions, you don't know what they are asking actually about. Alright, because like for example, when you learn these two parts, right, first part you learn about motor, the second part you learn about generator. Structure wise, with the one or two difference, the motor and generator are almost identical. Only a certain parts are a bit of difference, but other than that they are same. But the laws and the principle they are using a bit different, although they are related. Alright, So if you are not careful with this chapter, especially the second part, you may get a bit confused. So I hope please bear with me. So whatever I am talking to you together with the notes, please refer again and again to get a better understanding. Right. So start out with, we will cover the first part. Right. Please refer the notes which are already downloaded for you. If you can, please print it out and refer. Okay. So I am going into the first part. What is an electromagnet first? Okay. So first part, when you are talking about magnetic effect of a current, first you have to understand what is an electromagnet. What is an electromagnet? What is this? Alright. So simply put, in explain the electron, what is an electromagnet? Very simple answer. An electromagnet is a temporary magnet. That means the magnet is not going to be permanent. So it is a temporary magnet. That means it can create the magnetic effect on a metal, and then it can demagnetize it. You can forgo the magnetic effect from the same metal. Okay. So what happened here is the first part. So first you have to know what is an electromagnet first. Okay. So electromagnet, simply put, it is a temporary magnet. So how we can get a temporary magnet? Simple. You take a soft iron. Alright, you take a soft iron. Why soft iron? Because if you use other than soft iron, like for example steel, then you won't get electromagnet. You will get permanent magnet. Opposite to electromagnet is a permanent magnet. Okay. So let's say I have I take a battery. Alright, I wind I wind wire around it. Then I turn it on. Okay. I just turn on and then I off it. So when I turn on, this thing will become magnet. Alright, let's say I put some nails and all that. The nails will get stuck. Alright, with this. So the minute I turn it off, alright, turn on, the magnet will become magnet. When I turn it off, it becomes demagnetized. That means it doesn't become magnet anymore. So the nails will just drop. Okay, so it is a temporary magnet. That means simply you take a metal, soft iron, you wind it with a solenoid wire, insulated wire, connect to a battery, you turn it on, this metal becomes magnetized. So when you turn off the current, there is no more current, it's demagnetized. So it is a temporary magnet. That's why we call it as an electromagnet. So the first thing we are going to see, right? So the understanding of the electromagnet, I hope you got it. So the second part now we are going to see, that means whenever the current passes through here, in this conductor, it creates a magnetic field. So that magnetic field magnetizes the magnet. Alright? You can get, like for example, you take a needle. Okay, you take a needle, you take a magnet, you wipe the magnet around the needle for a couple of times, you can turn the needle into a magnet. That becomes a permanent magnet. Okay, but over here, the magnetic field it is passed to the soft iron that is come from the wire, and that soft iron now become magnetized. So what we are going to see in the first part is the magnetic field pattern. Field, I know what is field. What is field? Field is a region where you have a magnetic force. That's called the magnetic field. You have a gravity field, you have electric field, you have a magnetic field. So magnetic field is a field, a region where the magnetic effects takes place. That means the magnetic force exists. So any magnetic material, ferrous iron material you put, the thing can attract. There's a force exists there, right? Magnetic force. So what we are going to see here in the first part is, if you look at your notes I have already given just now, alright, in the first part, we are going to see how the magnetic field around a straight wire. Alright, around a straight wire, if I pass through a current, alright, I put a current here around a straight wire. Okay. How the magnetic field around it. Okay, I take a cardboard, right, I poke through the wire, then I see how the magnetic field around this wire. The second one, Let's say I take this is straight wire. Straight wire, the magnetic field. Straight wire. The second one is a coil. Okay. And of course the third one is solenoid. Okay, solenoid we got later. So over here, say take a cardboard. Okay, I same pass through the magnet over here, right? Current passes. Okay, so we are going to see how the magnetic field around this straight wire. So how to know there is a magnet? And magnetic field, as you know, it is a vector quantity. It is a vector quantity. That means it has a magnitude and then direction. Okay, it's a magnitude and direction. So that means the magnetic field, how strong the magnetic field, that means a lot of magnetic field around it, magnetic line of forces around it, and it also has a direction. So how to know direction? We can simply place a compass. Let's say you place a compass. So when you place a compass, when you turn on the current, you find that the compass maybe initially is showing not like this. But once you put around the current carrying conductor, the compass starts to show the magnetic field around it. That means the compass direction changes, right? Compass direction changes. So in this case, let's say it point like this. It goes like this. That means when the current passes like this, the magnetic field around it is. Okay, magnetic field usually use 3 lines, minimum 3 lines to indicate. Remember in SPM you draw 3 lines of forces. You draw 2, not enough. Alright. So when you put around, it's like this. Okay. So when you turn the direction of current, right? When you turn the direction of current, that means you change the polarity of the battery opposite. Alright. You find that the magnetic the compass, when you place, the compass starts to show now opposite direction. Okay, that means the compass, right, you put the compass, just now it was showing like this, now it will show this way. That means the field has changed direction. Okay, so there is a rule, right? We can simplify the rule with the direction of the magnet and the direction of the magnetic field. We call this as the right hand grip rule. You take your right hand, right, the thumb shows the direction of current, the fingers indicate the direction of magnetic field. So you don't need to put compass always to indicate. You can always use this simple rule to find. Simply, so when the direction of current is upward, the field is this direction, anti-clockwise. When you change the direction of current downward, the field is clockwise. Okay, the field is clockwise, the current is down. Okay. So we want to draw a simple, simplified way to show the direction of current up and down. So what we do, usually we draw a symbol to indicate. Let's say this is your cardboard. This is your cardboard. Alright. If the current is coming out, we put a dot. That means the direction of current is upward. Okay, the direction of current is upward, we put a dot. In the same cardboard, I put the current in it, okay, it's a downward, then over here I put a cross, a circle and a dot. Over here I put a circle and a cross. And this is to show the current is downward. Okay, why we are using dot and cross? Very simple. You take an arrow. Okay, arrow got a head and a tail. Alright? So when you look from here, the arrow is coming, the head is coming towards you, right? So when you look from the plan view, you see a dot. Alright? Similarly, if the arrow is leaving you, alright? So when you look at the arrow now, you see the tail is leaving you. So when the tail, it is cross, for the head, we put a dot. So very simple, right? So in that case, so upwards, dot, downwards, cross. So we use a right hand grip rule. When you see a dot, you put the thumb upward. So it is anti-clockwise. Okay, it's anti-clockwise. When it's down, it is, sorry, and when it's down, when it's down, it is like this, so it is clockwise. So this is how the direction of current in a straight wire and in a straight wire, okay, the direction of current change. Okay, now if you take a coil, similarly over here you can see the current is upward, dot is coming up, is here going in, cross. So over here, as you can see, direction of current, so the field is this way, right? Field is this way, so it is anti-clockwise. So you can see the current this way. Okay, over here in the solenoid, in the coil, the current is coming down. So when it comes down, so I take and draw the same 3 circles. So it is now clockwise over here. So over here, as you can see, right in the middle, the direction of the magnetic field is the same, alright, for this coil. So in the middle, the field is moving upwards, and when you have more number of lines, that means the field is strong, the high magnitude of field, okay. So over here we only learn qualitatively, alright. That means we don't count how many number of field, what is the strength of magnetic field by calculation. Right? There's a formula for that. That's only you learn in your A level. Right? So over here, what you have to know, when the field is, when you draw more lines, that means the field are stronger. When you draw less lines, the field is weaker. Alright. So for today, we get a short lesson. The solenoid part I'll discuss maybe in the next class. Alright, so you go through, we combine, take this and this, and then we can understand easily how for solenoid. We still use right hand grip rule, okay? So this is the thing that we learned today, right hand grip rule. Right hand grip rule, right hand grip rule. And we also sometimes known as Maxwell's screw rule. Okay, it's also in the notes, but I mean we just use one term now, right hand grip rule. Right? So right hand grip rule is to determine the direction of magnetic field in a current carrying conductor. Current carrying conductor got a magnetic field around it. The direction of the magnetic field we can use the right hand grip rule. So that's what we learned today. And then another concept we learn is electromagnetism. So these are the two things that we learned today. So please understand the direction of the field, how you use right hand grip rule, and how you use symbolically to indicate dot and cross. Okay, so the dot and cross will tell you the direction of magnetic field by using the right hand grip rule. Remember, the thumb for straight wire and coil indicate the direction of current. The fingers indicate the direction of magnetic field around the current carrying. This is what you have to know for today. So I'll continue in the next lesson with the solenoid, and we go with other concepts, application of electromagnet. How you use electromagnet in like the motor, bell, alright, circuit breaker and all that. You'll see that later coming classes. So please read your notes, go through this, so I think should be okay. So we'll meet till then in the next class and another one or day two. Till then, have a nice day. Bye-bye.